All right, let's dive right into this explainer. Today, we're dissecting a fascinating problem: how we are literally overcomplicating our digital lives by misusing the most advanced AI tools out there. Look, we're living in an era of explosive growth for large language models and generative AI, right? But according to some really eye-opening recent research, this boom has actually led us straight into a massive operational trap. We're going to explore exactly why throwing the most expensive AI at every single problem is, well, destroying our productivity, and more importantly, how we can flip the script to reclaim our time. Here's our roadmap for today. We'll start by unpacking the automation mismatch paradox. Then we'll introduce a really handy commuting analogy for AI tools and calculate the true cost of agentic waste. After that, we'll look at the counterattack, which is called vibe coding, discuss how to overcome AI fatigue syndrome, and finally, wrap up with the ultimate fix: local servers. Let's get into it. Section 1, the automation mismatch paradox. We've got to start with the core issue that's currently plaguing everyone from solo developers to massive enterprises. So here's the crucial point. A blind worship of agentic AI is causing a massive misallocation of resources. The source material highlights this widespread, honestly kind of mistaken belief that the most expensive, autonomous AI agent is somehow a silver bullet for every single automation problem. It's not. People are taking really simple, repetitive tasks that a basic, zero-cost traditional script could do flawlessly in milliseconds, and they're handing them over to high-latency, unpredictable AI agents. They're essentially using premium, high-end subscriptions meant for deep, complex coding to do, everyday mundane chores. Moving on to Section 2, the AI tools commuting analogy. To truly grasp this resource misallocation, we're going to use an extended metaphor based on something we all know: your daily commute. Matching the correct tech to your task is exactly like deciding whether to walk, take the bus, or hail a taxi based on the distance and cost. Think about it. If your destination is just downstairs, you walk. That's your traditional non-AI script. It's fast, it's free, and it's completely reliable. If it's a 30-minute trip, maybe you take the public bus, which is like using free AI models for basic drafting. Need regular fast commuting? You take the fast train. Those are your base AI subscriptions. Now, if you're going somewhere entirely unknown and complex, sure, take a taxi. That's your expensive agentic AI. And finally, if you need absolute privacy for sensitive materials, well, you buy your own car, which in our world means setting up a local AI server. Let's apply this framework to a classic, everyday scenario: getting real-time weather data from the Hong Kong Observatory. This is a highly deterministic, incredibly straightforward task. Now, what's really interesting here is that using an expensive AI agent to browse the web for the weather is literally like paying hundreds of dollars for a luxury taxi just across the street to the convenience store. On the left side, walking means using a direct API. It takes milliseconds, costs nothing, and is 100% accurate, zero hallucinations. But on the right, if you ask an expensive AI agent to do it, it has to decide to use a browser tool, write a search query, parse the HTML, and then summarize the text. It takes agonizing seconds, burns expensive tokens, and fundamentally risks hallucinating a weather forecast that isn't even real. It's a textbook case of overengineering. All right, Section 3, the cost of agentic waste. We really need to talk about what this overengineering actually costs you, especially when it's used for repetitive workflows. Because agents loop through these think, act, observe cycles, their token consumption doesn't just grow linearly, it grows exponentially. Traditional automation has a fixed near-zero cost, but an AI agent operates autonomously. Every single time it thinks or acts, it has to reread its entire past history just to maintain context. So round 1 might be 200 tokens, but by round 3, it's reading all the previous history plus the new inputs, jumping to 600 tokens. Unconstrained agents can easily run loops that end up costing 50 times more than a linear task. They literally turn daily automated chores into massive, exploding financial drains. Take sorting invoices, for example. A simple script fails clearly and cleanly. An AI agent, on the other hand, introduces a chaotic, expensive black box of unpredictable routing. The research highlights a real-world case of organizing PDFs into Google Drive. The deterministic script on the left is rock solid. If a field is missing, it throws a clear error you can fix in like 10 seconds. But the agentic workflow on the right, it might route the exact same invoice to different folders on different days just due to its probabilistic nature. Debugging it means reading pages and pages of AI thought logs just to figure out why it confidently hallucinated a completely wrong routing decision. No thanks. Which brings us to Section 4, vibe coding's counterattack. So how do we solve this? Well, we introduce a paradigm shift that flips the entire automation model completely on its head. Instead of using AI as a daily laborer to do the actual repetitive work, you use AI as a one-time architect to build a permanent script. This is vibe coding. It means you stop worrying about syntax, semicolons, and memory management. You focus entirely on the big picture, the vibe, or the core business logic, and you use natural language to command the AI to write the actual functional code for you. Coined by Andrej Karpathy, this approach empowers literally anyone to build production-level, deterministic tools without needing a computer science degree. You just describe what you want, and when the code inevitably throws an error, you don't even read it. You just copy the error log, paste it right back to the AI, and tell it to fix it. This is responsible AI development, creating a traditional, solid, zero-cost tool that you can rely on every single day. I love this part. It brilliantly illustrates a real David versus Goliath dynamic. A persistent free user easily outsmarts a rich, impatient user just by investing in permanent infrastructure. Imagine a task where you're filtering 50,000 rows in Excel daily. The impatient paid user lazily uploads this massive file to their AI agent every single day, risking context limits, missing data, and racking up high API costs. But the persistent free user, they spend a weekend bouncing errors back and forth with a free AI model to vibe code a 1,500-line Python script. Once it's done, they run that non-AI script locally. It's instant, it has absolute accuracy, and it's free forever.
Section 5, overcoming AI fatigue syndrome. Because listen, the cost of misusing AI isn't just financial. There is a massive psychological toll and mental drain here as well.
Industry veteran Steve Yegi actually describes this misuse as an energy vampire. It literally sucks the creativity right out of our workflows. While AI can definitely provide massive productivity spikes on single tasks, handing off entire complex pipelines to autonomous agents actually fundamentally changes the nature of your job, and really not in a good way. Let's dive into this. When you hand off entire workflows to unpredictable agents, you stop creating and you start desperately auditing their mistakes. You are downgraded from a creator to an exhausted reviewer of what the industry is now calling AI slop. Because here's the thing. AI doesn't actually compress human labor time if you have to meticulously verify every single output for hallucinations. You often end up spending way more time untangling the messy logic of an autonomous agent than you would have spent just vibe coding a simple deterministic script in the first place. Which brings us to our final section, number 6, the ultimate fix, local servers. This is the absolute peak of our commuting metaphor for those of you who need total privacy and zero ongoing costs. We are talking about buying your own car.
See, if you are handling sensitive medical records, enterprise-level code, or proprietary financials, you absolutely cannot take the public bus. You must run local models to guarantee absolute data privacy. Sending sensitive data to cloud APIs, even with all the privacy toggles flipped on, it breaks strict compliance rules. But by running open-source models on local hardware in an air-gapped environment, you achieve 100% data sovereignty. Your data literally never leaves your machine.
And this builds into a really critical hardware choice: raw speed on a PC versus the massive memory advantage of a Mac Studio. On the left side, NVIDIA PCs dominate raw speed and the whole CUDA software ecosystem, but they are severely bottlenecked by VRAM. Running enterprise-level massive models requires stringing together multiple crazy expensive graphics cards. On the right side, Apple's silicon machines like the Mac Studio use a unified memory architecture. The GPU can directly access 64 or even 128 gigabytes of system memory. That allows a single, quiet, low-power machine to easily run massive 70 billion parameter open-source models natively. It's a game changer. For the ultimate resourceful user out there, you can actually reroute expensive subscription tools right to your local machine and build your infrastructure completely for free. The research outlines this genius hacker workflow. You take a premium, expensive terminal tool like Claude Code, change its environment variables, and point it away from the paid cloud API, directing it right into your local machine running a free open source model through Llama. You get an elite coding environment, but you are vibe coding in total privacy and paying exactly $0 in API costs. We're going to leave you with this final thought to chew on. Are you paying AI to be your daily laborer, or are you utilizing AI to be the architect of your future? Master the tools, write the scripts, and reclaim your digital workflow. Stop paying expensive AI to do mundane chores. Use it to build deterministic, reliable assets that work for you forever. Thank you for joining me on this explainer to explore this critical shift in how we work. Until next time, keep optimizing.